The purpose of the lab this week is to build an electric motor and measure how fast it spins. In order to do the lab successfully, our group used a holder, some wires, a power supply, two magnets to build an electric motor. An electric motor is an electrical machine that converts electrical energy into mechanical energy. Electric motors operate through the interaction between an electric motor's magnetic field and the winding currents to generate force within a motor. According to the principle of the electric motor, we began to build it. The holder has 4 metal plates. We attached 2 magnets to 2 plates, offering a magnetic field. Then, as is shown now, we used a long wire to wind the plastic cube with a metal stick to form a winding circuit. We inserted the metal stick into other 2 metal plates. Afterwards, we linked the power supply to 2 sides of the wire to form a winding current. According to what we have learned in the last week lecture, a magnetic force would exert on the part of the wire perpendicular to the direction of the magnetic field, and the force is equal to ILB. However, when we added the power supply to 2 sides of the wire, it didn't spin and nothing happened. We thought that maybe the magnetic force is not big enough to enable the wire to spin. According to the formula, the magnetic force is equal to BIL. So we tried to increase the magnetic field to increase the force. At a second time, we used 4 magnets to form a bigger magnetic field and then linked the power supply to the 2 sides again. As a result, the wire still didn't spin. With the help of the drone, we know that the wire was with plastic outside, which cannot be conductive. So we used tools to polish the wire and attempted at the 3rd time. In this time, the electric motor spun successfully, and we increased the voltage to increase the current flow in order to make the wire spin faster. Finally, we started to measure how fast it spins with an oscilloscope used to observe the change of the electrical signal over time, such that the voltage and the time describe a shape with continuously graphed against a calibrate scales. We linked the oscilloscope to the ends of the power supply to measure the voltage and did the same step again to make the wheel spin. We could observe that there was a periodic graph on the screen and a drop happened after a same interval. As John said, every 2 drops means a revolution. We read the squares on the screen. There are 8 big squares with 2 small ones, and as is shown, every big square means 25 million seconds. So it took about 210 million seconds to complete 3 terms. In other words, it took about 70 million seconds to finish a spin. Actually, I didn't know why every 1 drop means it spins a half. After I attended the lecture this Friday, I supposed that maybe it has a relationship with Nernst's law. When the wire becomes horizontal, the magnetic flux will decrease to 0 due to the areas becoming small. According to the Nernst's law, a changing magnetic field will produce a current in a direction which attempts to maintain constant magnetic flux. There was a new current in an opposite direction trying to maintain constant magnetic flux, which leads to the drop of the voltage. To sum up, This week we did the lamp successfully and got the speed of the electric motor. Also, we connected it to the Nernst law to get a better understanding.